Okay. Basic trig. SOHCAHTOA. Please write SOHCAHTOA like this. Who taught you SOHCAHTOA? Anybody? Did Thorson write it like this? Yeah, I think this is the best way to do it. You remember how I had the wing way from Connor Wing? I believe it was Michael Bjork told me if you use SOHCAHTOA like this stands for sine, cosine, and tangent. And he said if it's a ratio where it's like a fraction and one is on top and one is on the bottom, why don't you just write it as a ratio when you write SOHCAHTOA? And I was like, well, that's exactly what I should do. What does O and H stand for?
Opposite, adjacent.
Nope. Hypotenuse. That's not HH. That's not how you spell hypotenuse. Hypotenuse. I was literally about to ask you where it was, and then I was like, that's silly. Why would Carly know? And then Carly, you were like, it's over there. I knew I should have. Hypotenuse. This is the one that Sam was thinking of. That's adjacent. This one is hypotenuse, opposite, adjacent. Tangent, sine, and cosine are just relationships between different sides of a right triangle. So we're going to draw a right triangle really quick. You can tell it's a right triangle because it has a 90 degrees in it. Okay, which side is the hypotenuse? The slanty one, otherwise known as opposite the right angle. How do you know which one is the hypotenuse and which one is the adjacent side?
That's where your degree is.
It depends on what angle we're talking about. Now, often in trig, we use this symbol for, like, you know how often when we're trying to find a variable, we often use x? This is a Greek letter called theta. Like if you're watching a sorority movie and it's like Kappa Kappa Theta. That's just an unknown angle, but it tells you which angle we're referring to. So if we're talking about this angle, where is the opposite? Yeah, the one that goes up. So it's the one that is not touching this angle over here. And adjacent is the one that's not the hypotenuse but is touching the angle. So do you see that if I had written theta up here, then the adjacent one would have been this one instead, and the opposite one would have been over here? But the hypotenuse would have remained the same no matter what. Okay. There are two types of problems you can do. One is finding out the side of a right triangle, and one is finding out the angle of a right triangle. Do you remember how to do both of those from Thorson? No? Okay. Example 1. I'm just going to make this one up. All right, let's say that this angle is 59 degrees. And this side is 12. And I want to find this one. You're definitely going to need a calculator if you don't have one already. All right. So here's how you do this. Here's my angle. Which sides do I have?
The adjacent and
This one is adjacent, and then this one is hypotenuse. I know I don't really know what the adjacent one is, but do you see how that the opposite side doesn't even have anything listed there? Not even a variable? So this is a problem a ka program, as in like if you hurt your toe, you might need to go SOHCAHTOA. Ka, so it's going to be cosine. Oh, and please do me a favor. Absolutely nobody in here nobody in here ever say cos or sin. Sin, it does not save you time. It's sine. And cosine, I mean, cos, it's not a big time saver. It just, I don't know. It bothers me because it's just a simple thing to say. So sine, cosine, and tangent. No tans, no sins, no cos. Don't do it. Don't do it as a joke. Don't do it. Nope. Don't do it. No sin tan. All right. Sine, cosine, tangent. All right. The cosine of 59 is, how do I know which one goes on top of this fraction?
Because the A comes first and cut.
Right. So A is on top. So that's x over 12. Solve this problem, it's pretty simple. Put this one over 1. How do you solve a fraction equals a fraction kind of problem? Cross multiply. X times 1 is 1x. The other side is 12 times the cosine of 59. All right, now, answers like this can be in degrees or radians. Do you guys remember me telling you about radians, that they're just kind of like miles and kilometers? They both measure angles, but they measure it differently. So everybody, let's check your calculators. Everybody go to your mode next to, right next to the second button, it says mode. And then go down and make sure that the third thing, that degrees, is highlighted and not radians. Then hit second quit. And this time you're going to type in 12 times the cosine of 59.
Wait, what if radian is highlighted?
Then use the arrow and go over to degree and hit enter. 12 cosine 59. I got 6.18. You guys get 6.18? That means this side of the triangle is 6.18. Now, is that a reasonable answer for this? Yeah, I mean, it's not a perfect drawing, that's for sure. And if it was actually to scale, then it would actually look like it's half of that side, but it's pretty close. Are there stupid answers in math?
Yeah.
Oh, yes. Oh, yes. Tell me a stupid answer for the side of a triangle. Yeah?
Any negative.
Any negative number, because it definitely needs to be a positive number if the triangle exists. Okay, yeah?
If it's longer than 12.
Right, 12 is definitely the longest side. It's the hypotenuse, so anything longer than 12 is a bad idea. So it needs to be definitely somewhere between 0 and 12. But if you end up doing your math and you have like radians in there by mistake and you end up with 42, don't write it down. Use some brains, okay? Or negative 42, that's totally wrong. Use some brains. Okay, you want to practice problem with your partner?
I like this.
Is he still on the word top?
What?
All right, find x. Talk to your partner, please.
We start from negative, so 50. So actual top is right. I said, so if I just say half, and we have, well, we drop that. So let's do it again. So we have these two, O and A.
If you both get caught up, call me over.
Which one has both O and A? Okay, so we need from O and A, right? Which one has O and A? Top. All right. And here. So O comes first, so now we sit. That's,
Opposite.
no, it's A, wait a minute, opposite, it's A, sorry, that's. So, yeah. That's that.
Or maybe
Oh, yeah, that's, oh, yeah, okay. I was just checking, no, yeah, that's it, because we were rectangle multiplication. So, if you cancel this out, it's 8, right?